friends, this is Mohammed Sarwar from Veltech University. This is my final year presentation for project. This is our college name and logo. I am from mechanical department. Our college is accredited with NBA accreditation program, as you can see here. This is my project title: enhancing the heat transfer rate through the radiator using Al2O3 with water nanofluids. My name is Mohammed Sahbaz, and you can see my name is at the first. My team members are MD Fahim Mustafa, Mrityunjay Rai, and our project guide is Alex George A. Our batch number is B20. This is our abstract, what we are going to do in our project. As you can see, nanofluid is a mixture of nanosite particles of less than 100 nanometers suspended in liquid medium. This project focuses on the role of nanoparticles of different concentration in the heat transfer. In this project, a series of experiments will be performed to obtain the heat transfer advantage of using nanofluids instead of water. The particle we have used in this project is alumina with water. It is a nanosite particles of 20 to 30 nanometer size. We are mixing it with water to make nano. The purpose of the project. This is our purpose of the project. The purpose of the project is to study and further understand the role of nanofluids in heat transfer. The performance of nanofluid will be evaluated using variable alumina with water nanofluids of different chemical composition and concentration. Concentration means we can add different concentration like 0.1 concentration of nanoparticles in water, 0.2, 0.3 and up to 0.5. The major variables in nanoparticles role, what effect of heat transfer will be there from nanoparticles. We are using it with water. Then after that we will experiment will be designed and we will calculate the heat transfer difference between the water and the nanofluid. This is the introduction. As you can see here, in automobile industry's application, water is commonly used to transfer the heat through the radiator for cooling engine. Water is most commonly used liquid in radiator in automobiles since it is easily available, cheap and safe. But it is not a very good thermal conductivity, so therefore we have used nanofluid, so that is the heat transfer rate can be increased and the thermal conductivity and viscosity can also be increased. We have not used microparticles since it will lead to abrasion and sedimentation inside the radiator. These are the literature survey we have studied. We have gone through several papers, as you can see here. These are the authors in 2014, 2011 and 2015. These are the paper we have referred for doing our. The material requirement for our project is alumina, deionized water, lab glass beaker of size 250 ml, spatule, vials, gloves and mask, weighing, testing and experimenting machine. This is the particle we have purchased from Nano Labs. As you can see here, you can see alumina. This is the water we are using, and these are the lab equipment we will be using in our project. This is how we have separated the particles based on the weights. As you can see here, this is the accuracy weighing machine which can accurately weigh the particle based on their weights, in which is accurately we can separate them in terms of grams, 0.1, 0.2 concentration we have calculated, and then we have separated the particles. You can see there we have separated the particles and folded in a page. These are the tests we are going to do for nanoparticles. XRD tests, this means that analysis of particle and phase composition, what is the phase present, alpha, beta, gamma, what phase it is, we can identify from there, and what type of nanoparticles it is, and we can get from XRD test. Same test, scanning is electron microscopy. Analysis of size of the particle, what is the size of the particle we can determine from same test. Spectroscopy is employed to measure the amount of light that sample has absorbed. This is the study test we have got. The result, as you can see that it is compared with the copper particles, and we have found that it is aluminum. And this is the result of same test, and we have, as you can see there, here it is showing 20 nanometer and 50 nanometer. So the average particle size is 20 to 30 nanometer. This is the spectroscopy result, how the light is affecting the aluminum. This is a method of preparation of nanofluids. We can prepare by two methods. Ultrasonic waves are generated in a liquid suspension by immersing an ultrasonic probe into the suspension. This is called direct sonication. Another method is by introducing the sample container with the suspension into a bath containing a liquid through which ultrasonic waves are propagated. This is called indirect sonication. So we have used indirect sonication. This is the, you can see the apparatus for indirect sonication. It is ultrasonic bath. You can see at 20 degree, at 22 degree we have seen that we have mixed the particles in water. This is the preparation of nanofluids, how we have prepared the nanoparticles based on the calculation. 0.1 concentration contains 0.2 grams of nanoparticles and 50 ml of deionized water. And so you can see 0.2, 0.3 and 0.4, 0.5 concentration based on the weights and 50 ml of. This is how the, after preparing 0.1, 0.3 concentration, as you can see here, 0.1, 0.2, 0.3 concentration have been prepared, and this is called nanofluid. These are the characteristic tests for nanofluid. Stability test is to check the stability of nanoparticles in order to check the sediment formation of nanoparticles in base water. Viscosity is used to check the viscosity of nanofluids at different temperatures. Thermal conductivity is used to check thermal conductivity of water. From here we can determine what is the thermal conductivity of the nanofluid, and then we can compare it with water. This is the stability test result, which says that how far the particle is dispersed in the water, how quickly it is dispersed in the water. From here we can determine. You can see it is above 61,60,000 particles has been dispersed in water by giving voltage. You can see there. This is the viscosity result we have got, and we have prepared the graph based on that. As you can see, as the particle concentration is increased in water, the viscosity is also increased. This is the apparatus used for thermal conductivity test. This is the KD2 probe instrument, which is used to determine the thermal conductivity of the nanofluid. Thermal conductivity result what we have got from the thermal KD2 probe instrument, and it is 0.1 concentration 0.72 watt per meter centigrade, and for 0.2 concentration 0.78 watt per meter centigrade, 0.3 concentration 0.82 watt per meter centigrade, 0.4 concentration 0.86 watt per meter centigrade, 0.4 concentration 0.94 watt per meter centigrade. This is the result we have plotted on a graph. As you can see, it is increasing on as the particle concentration increase, the thermal conductivity is also getting increased. Reynolds number also Nusselt number, we have conducted the experiment, and we have got the result, and we have calculated the effect of Reynolds number, and how the Nusselt number is getting affected with the increase of Reynolds number. As you can see, as the Reynolds number is getting increased with the increase in particle concentration, and the Reynolds number is the Nusselt number is also getting increased, and we have compared it with pure water, and we have shown 0.1, 0.3 concentration of nanoparticles in water. As you can see, the Nusselt number is more than pure water, as the particle concentration. Coefficient of heat transfer versus Reynolds number. This is the graph we have got. As the particle concentration is getting increased, the heat transfer coefficient is also getting increased with the increase in Reynolds number. As you can see, it is more than pure water. Overall heat transfer coefficient versus Reynolds number. This is how we have calculated the overall heat transfer coefficient. As you can see that as the particle concentration is getting increased, the overall heat transfer is also getting increased with increase in Reynolds number, and also with it is compared with pure water, and we have found the result that it is more than pure water. So the heat transfer rate is more than pure water when using nanofluid. This is the characteristics of an aluminum nanoparticles. Aluminum oxide alpha phase 99.5% pure. Average particle size is 20 to 30 nanometer. Color is white. Surface density is 120 to 140 meter square per gram. Crystallographic structure is rhombohedral. Atomic weight and magnetic attraction is none. Density is 3.97 gram per centimeter cube. Melting point is 2055 degree. Morphology is this is the schedule of project, how we have done our project from January to April. You can see here what are the things we have done. Literature survey, purchase of particles in second phase. Third phase we have done evaluation of nanofluid, and fourth phase report. This is the work allocation of the group members, what we have done in our project. This is the conclusion we have read. Nanofluids are mixture of nanoparticles in base fluid which have a higher thermal conductivity than the base fluid. Since the shape and the size of the particle, the volume fraction of nanofluid, types of base fluid and nanoparticle, and the type of particles are factors that affect thermal conductivity enhancement of nanofluids. The effective thermal conductivity and viscosity based fluid increase considerably due to the addition of nanoparticles. The relative effective thermal conductivity of nanofluid increase with increase in particle concentration and is generally higher than the predicted by the Maxwell model. Nanofluid exhibit excellent heat transfer capability with the increase in Reynolds number as well as particulate concentration. The Nusselt number of the nanofluid increases with volume fraction as well as the flow rate. The obtained values are compared with values reported by the researcher and found to be good agreement, and the enhancement of thermal conductivity leads to increase in the heat transfer performance as well as the viscosity.